Which combination of the following statement is correct? Okay. For which one? The incorporation of reheater in a steam power plant. When I keep the reheater in the steam power plant, what happened? So the P statement, they have given a 4 statement. P statement P always increases the reheater always increases the thermal efficiency of the plant. Reheat always increases the dryness fraction of the steam at the condenser inlet. Reheat always increases the mean temperature of the heat addition, and reheat always increases the specific work output. Okay, these are the 4 statements. See, I am emphasizing again and again, in reheat. Okay, see what happened whenever I say efficiency increasing. Okay, what are the different processes? P boiler, by increasing the P boiler, mu increases. By increasing the superheat temperature, okay, then what happened? The efficiency increases. By regeneration also, okay, mu increases. Even by decreasing the P condenser, by decreasing the P condenser, mu increases. These are the 4 standard statements. Okay, whenever you see these without thinking anything, you can always say that mu is increasing. In case of regeneration, increasing the boiler pressure, or increasing the superheat, or reducing the condenser pressure. Why in all these cases, except this, what is happening? The mean temperature addition at mean temperature at Q addition is always increasing here in this case. Here in this case, what is happening? T mean at the Q2 is decreasing. Okay, so here in this case, T mean at the Q2 is decreasing. That is why the efficiency is increasing. Okay, but in case of the reheat, what is happening? In case of reheat, what is happening? Whenever I increase the boiler pressure, then what is happening? Of course, the Tm at Q1 is increasing, but the dryness fraction is decreasing. Whenever the dryness fraction is decreasing, a moisture content is decreasing. To avoid that, okay, so instead of 1 turbine, I am using the 2 turbine and then reheating, so that when reheat, what is happening? The moisture content is decreasing. But in the examination, if you don't remember all these, and then how will you do this? By drawing the simple drawing of the reheat. So if I draw the simple drawing of the reheat here on the TS diagram, okay, so it will be, initially it is heated like this, and then initially it will be like this, and then expanded up to this point, and again reheated to the same temperature generally, and then expanding like this. It should have been more steep, okay, but anyway, so this is a process here. Okay, this is a process. So 1, 2, 3, 4, 5, 6, 7. So this is the process. Okay, reheat. So here in this case, where is the reheat happening? The reheat process here is 2 to 3. 2 to 3 is the reheat process. Okay. So here, where is the WT? WT equal to H1 minus H2 plus H3 minus H4. Okay. So without reheat, it would have been simply, extended up to here. So this much portion. So when there is no reheat, then it could have been from here to here, but this much extra is added. That means W2 is increased here. W2 is increased. Okay, and without reheat, the dryness fraction is here 2 dash. Okay, but with reheat, the dryness fraction, at the exit of the turbine or at the inlet of the inlet of the condenser. Okay, what happened here? So always this dryness fraction is increasing towards the right side. So X4 is greater than the X2. So that means X is increasing. Dryness fraction is increasing. Okay, then what is a R? R is a mean temperature at the heat addition. So what happened to that? See, this depends on the this depends on the how much this 2-3 process is affecting. See, without this, let's assume without this, that Tm would have been like this. Without reheat, the Tm would have been like this. Let's call it as a Tm1. Okay. But with this, what is happening? You may think that again it is going this much high, so the Tm may increase. But what is happening here? The Q1 also increasing, right? We are previously only let's assume 100 kilojoules. 100 kilojoules Q is given. Now extra 50 more is given. So whenever you give extra also, then automatically what happen? It may decrease. Okay. It may decrease also sometimes. Okay. But this area increase because of that, it may increase also. So it's only based on the exact values. Okay. Without knowing the exact values, you cannot decide whether TM2 is what is that? TM2 is whether either greater than or less than the TM1. Either can be happening. Any one of these can be happen. So only by knowing the exact values we can calculate this. So we cannot say that always it is increasing. Okay. So the efficiency, now how will you find out whether the efficiency is increasing or not? Okay, efficiency is a function of the Tm here. Okay, the mean temperature at the Q1. Okay, not about the W or how much Q1 you are giving. It is based on the mean temperature at the heat addition. But here, the heat addition, mean temperature at the heat addition is a confusing value. We don't know whether it is increasing or decreasing. When we don't know whether it is increasing or decreasing. Here also, we cannot exactly tell whether the efficiency is increasing or decreasing. Okay, so here, since they used it is always, so we cannot tell this. So P is wrong, Q is right, R is wrong. Why? Because here they use the word always. It is increasing, but it could be it could either increase or decrease, and always the specific work is increasing. Okay, so what are the correct options here? Only Q and S. So which option is matching? Only Q and S. Option B. So option is B. Okay. Intentionally I am spending more time and again explaining whatever we already covered in the theory. Okay. So that you should not make any mistake in the examination. Okay.